Next, we will study steepest descent algorithm. The steepest descent algorithm is an optimization technique used to find the minimum of a function. It iteratively moves towards the minimum by taking steps proportional to the negative of gradient or slope of the function at the current point. This method is commonly used in adaptive filter design to update filter coefficients and minimize errors. So we first study the steepest descent algorithm using single weight by using this weight equation where mu is the constant controlling the speed of convergence. Let us take an example. In this example, a quadratic um, MSE function for the Wiener filter is given as this, and we are asked to use steepest descent algorithm with these values to find the best weight and determine j minimum by iterating 3 times. So firstly, we will use this quadratic function j, and we will take its derivative with respect to w of n. By taking its derivative with respect to w of n, we got this equation. Then we have to perform 3 iterations for n is equal to 0, n is equal to 1, and n is equal to 2. Then I have put n is equal to 0 in this equation, and I have multiplied it by mu because the weight equation was this. So I have multiplied it by mu and I have got this value, and then I have updated the coefficient by using this equation as mentioned before, and I have updated the coefficient. Similarly, I have performed the next 2 iterations and calculated the updated coefficients, and after the third iteration I have got the value of the weight as 0.992. This is our desired weight, and by using this weight we will calculate the minimum j value, and which is 30.0006. Now we will study LMS algorithm, least mean square algorithm. The least mean squares algorithm is an adaptive filtering algorithm that iteratively adjusts filter coefficients to minimize the mean square error between the filter's output and the desired signal. It updates the coefficients by taking small steps proportional to the error and the input signals, making it simple and widely used in real-time signal processing applications. This is the system. This is a desired signal. This is the noise which is provided to adaptive filters. This is the output of adaptive filter, and this E of n is the error, which results in difference between desired signal and the output of adaptive filter. By observing this system, we have to write LMS algorithms. So initially I have set the weights to 0 because they weren't provided, and this y of n adaptive filter equation is given, so I have written it as it is. E of n is the error probability. This is us in difference between a desired signal and a y of n, so I have written it here. Now the equations for updating the weights are given here, and since we were asked to find uh, two weights because we're two tap filter, therefore I have written equations for W0 and W1. Next we will consider adaptive filtering using LMS. We first study the noise cancellation problem using a simple two-tap adaptive filter, and we have assumed some data here. The purpose of doing so is to become familiar with the setup and operations of the adaptive filter algorithms. So I have used this system. So I have used this system and performed several iterations to observe that how adaptive filtering uses LMS to reduce noise. So in the first iteration, starting with n is equal to 0, I have put 0 in all the LMS algorithms which were found before. I have put y of n to y of 0 and e of 0, and I have calculated all the values for the first iterations, and I have dated the coefficients because initially the coefficients were set to 0, both w of 0 and w1 were 0. So I have used 0 values here, and I have found the new values, updated values of the coefficients. So nextly for n is equal to 1, I have performed the same steps, and the same procedure will be performed for n is equal to 2. You can perform several iterations up to the value where you can observe that the adaptive filter has now understand the noise characteristics and it has starting to reduce noise. Hmm. Finally, we will go through some of the basic applications of adaptive filters. Since adaptive filters have self-adjusting characteristics, so they have various applications, but here we will consider the major two applications, which are the ECG interference cancellation and echo cancellation in telephone or telecommunication systems. So, firstly, we will go through ECG interference cancellation. Adaptive filters play a very crucial role in ECG interference cancellation by dynamically adjusting their parameters to filter out noise and unwanted signals such as power line interference or muscle artifacts from the ECG signals. This ensures a clearer and more accurate representation of heart's electrical activity, improving diagnostic reliability. Moving towards echo cancellation. In telephone systems or in telecommunication systems, adaptive filters are used for echo cancellations for dynamically adjusting to the varying characteristics of the echo path. They identify and subtract the echo from the received signal, thereby improving call quality and clarity by eliminating the distracting echo heard by users. So that's all from the chapter of adaptive filters from D10 book chapter 9. Thank you.